According to Statista, factories worldwide produce more than 200,000 tons of candied fruit each year. That is astonishing for something made from fragile oranges, lemons, and cherries that normally rot in less than a week. Sugar turns perishable fruit into a shelf-stable product that lasts 12 months or longer. How can something so delicate endure this intense process without falling apart? To find the answer, we step inside the factory. Candied fruit dates back to the Byzantine Empire, when cooks preserved produce in honey. By the 1500s, European confectioners replaced honey with imported sugar, making the product sweeter and longer lasting. In Italy, candied citron became essential for panettone. In France, orange peel brightened Christmas cakes. Immigrants brought these traditions to America, where fruitcakes and holiday breads became holiday staples. For many families, candied cherries recall festive kitchens and seasonal celebrations. Beyond its bright colors, this simple product connects centuries of culinary history with the nostalgia of modern holiday tables. The journey begins in the orchards. Firm, resilient fruits that can withstand both heat and syrup, such as cherries, pineapples, oranges, kiwis, citrus peels, and even ginger, are the most common choices. Here, specialized harvesters clamp onto the tree trunks and shake them with hydraulic arms, delivering nearly 3,000 vibrations per minute to bring the fruit down. Ripe citrus and cherries fall into padded catching frames that prevent bruising. Some harvesters use conveyor arms to sweep the fruit into large bins. A single machine can gather up to 80,000 pounds of citrus in one day, doing the work of dozens of pickers. From the fields, trucks transport the harvest directly to the factory. The goal is speed. Freshness depends on getting the fruit from tree to plant within just a few hours. Inside the plant, the fruit enters the cleaning line. The first stage is immersion. Tons of citrus and cherries are released into stainless steel basins filled with flowing water. Gentle paddles stir the liquid, keeping the fruit in motion so mud, dust, and stray leaves float away. After soaking, powerful spray nozzles rinse every surface with high-pressure water. Each nozzle delivers about 60 pounds per square inch of pressure, strong enough to wash away pesticide residues and sticky sap without damaging the delicate skins. Next, rotary brushes scrub the fruit. These spinning bristles polish the skins, remove stubborn residues, and leave the surface glossy. By the end of this step, the fruit is both clean and food safe. Once washed, the fruit moves into automated sorting machines. Optical sensors scan each piece under bright LED light, checking size, shape, and color at a rate of 10 pieces per second. Air jets then blow aside any bruised or misshapen fruit. Only uniform pieces make it through. Now the fruit is shaped and prepared. Industrial knives peel skins, remove seeds or cores, and cut slices or wedges at up to 1,200 rotations per minute. For citrus peels, there's one extra step. They are soaked in salt water or blanched in 90 degrees Celsius baths for about 5 minutes, then quickly cooled. This process softens the peel and removes bitterness, while preserving its natural aroma. Here comes the stage that transforms fruit into candy. The slices are submerged in stainless steel vats filled with up to 1,500 liters of hot syrup, made from cane sugar or glucose. Vacuum pumps lower the pressure to 0.8 bar, drawing water out of the fruit while pulling sugar in. Over 12 to 48 hours, through repeated cycles, the sugar content slowly rises to between 65 and 75%. When the fruit is ready, workers stir gently with large steel spoons to test the thickness of the syrup and separate any pieces stuck together. Using slotted spoons, they lift the fruit in 10-kilogram batches, letting the syrup drain back into the vat. The pieces are spread across perforated trays. Here, the human touch makes all the difference. With forks or tongs, workers flip each slice so the syrup doesn't pool on one side. This patient step ensures that every piece dries evenly, with a smooth, glossy finish. Workers spread the coated fruit evenly onto wide metal trays. Each tray is stacked onto wheeled racks, then pushed into large industrial ovens. Inside, warm air circulates steadily at around 55 degrees Celsius for several hours. The gentle heat draws out excess moisture while preserving flavor and texture. By the end, the fruit emerges chewy, sweet, and shelf-stable. From there, the process slows down. Workers scoop the glistening fruit by hand and portion it into containers. Some jars are packed piece by piece to highlight uniform color and size, while larger trays are filled in layers so the sugar coating remains intact. Each movement is deliberate, placing, adjusting, pressing the lid closed. Once filled, the jars and trays are slid into sturdy cardboard cartons. Finally, the shipments leave the plant, bound for supermarkets and specialty shops. What began as fresh fruit in the orchard now sits ready on store shelves, polished by hand at the very last step. But no sweet connects more deeply to American childhood than the soft white cloud of marshmallows. According to the National Confectioners Association, Americans consume over 90 million pounds of marshmallows every year. So how does a factory trap air and sugar in perfect balance? The answer lies in a precise, fast-moving process. The earliest form of marshmallow came from the sap of the mallow plant used in ancient Egypt. Priests mixed it with honey for ceremonial sweets. By the 19th century, French confectioners replaced the sap with gelatin, making production faster and more reliable. This change marked the birth of the modern marshmallow. In the United States, the candy gained popularity in the early 1900s. By mid-century, it was a staple in hot cocoa, Rice Krispies treats, and backyard campfires. Production begins with gelatin, either in sheet form or fine powder. Instead of hydrating separately, it goes straight into massive stainless steel kettles, where hot sugar syrup, corn syrup, and a touch of vanilla are already cooking. Steam jackets bring the mixture to about 118 degrees Celsius, known as the softball stage in candy making. At this temperature, the syrup reaches the right thickness while the gelatin dissolves evenly, binding the mass into a smooth, elastic base. The hot syrup meets the hydrated gelatin inside high-speed mixers. Stainless steel blades rotate at up to 1,500 revolutions per minute. Air is injected under pressure, creating thousands of microscopic bubbles. These bubbles, suspended by gelatin, give marshmallows their cloud-like texture. Can you believe that nearly 50% of a marshmallow is nothing but air? That invisible ingredient is what makes each piece light yet resilient. The fluffy mixture is pumped toward forming lines. Some factories use extruders that push it through long nozzles, creating endless ribbons of candy. Powdered sugar or cornstarch dusts every surface, preventing the sticky foam from clumping. Conveyor belts carry the pieces forward in neat rows. Sharp blades slice the ribbons into equal cubes at speeds of 300 cuts per minute. Other lines use depositing heads that squirt shapes directly onto moving belts. In minutes, shapeless foam becomes uniform pillows, or twists ready for the final touch. Automated weighers drop exact amounts into plastic pouches. A heat-sealing bar closes each bag in under a second. By day's end, one plant may produce more than 1 million marshmallows. From a bowl of syrup and gelatin, factories create clouds that survive the journey to campfires and kitchens across America. If marshmallows felt sweet enough, the next treat is far more colorful than you can imagine. Each year, Americans eat more than 16 billion jelly beans, according to the National Confectioners Association. That is enough to circle the Earth nearly 5 times if placed end to end. What makes this figure even more surprising is the effort hidden behind each bean. A candy only 2 centimeters long takes dozens of hours to create. From boiling sugar to spinning drums, the process requires more machinery than most people imagine. So how does a tiny candy demand such a massive operation? Let's step inside the plant. The jelly bean first appeared in the United States during the late 1800s. Confectioners experimented with sugar-coating techniques borrowed from Turkish delight and other candies. By the 1930s, jelly beans had become a symbol of Easter. Their egg-like shape and bright colors linked them naturally to holiday traditions. Children hunted for them alongside chocolate eggs in backyards across the country. Today, jelly beans are available in thousands of flavors, from classic cherry to buttered popcorn. More than a treat, they represent a cultural tradition tied to American celebrations. Every batch begins with corn syrup, sugar, and starch poured into giant kettles. Heated to nearly 150 degrees Celsius, the mixture thickens into a glossy liquid. Mechanical paddles stir the syrup constantly. Without movement, the sugar would scorch, creating bitterness instead of sweetness. At peak production, one vessel can handle over 1,000 liters at once. The hot syrup travels to molding machines lined with trays of cornstarch. Small cavities in the starch act like tiny molds. Nozzles inject a measured drop of syrup into each cavity. The starch holds the liquid in place, allowing it to cool and set into chewy centers. After several hours, workers shake off the excess starch. The beans, still pale and soft, roll forward to the next stage. Thousands of imperfect nuggets will soon transform into glossy candies. The centers tumble into massive rotating pans. Workers add thin layers of sugar syrup, each one drying before the next is applied. The process repeats hundreds of times. Slowly, the beans grow firmer as layer upon layer builds their outer shell. Would you guess how many coats of sugar cover a single jelly bean? The answer is astonishing: over 200 delicate layers. Once the shells are stable, liquid dyes and flavorings pour into the tumbling pans, coating each bean evenly. Heat lamps at about 40 degrees Celsius speed the drying so the colors set firmly onto the surface. Afterward, operators dust in about 3 to 5 kilograms of fine sugar per batch of 50 kilograms of beans. As the pans roll, you can hear the steady rattle of thousands of beans striking the copper walls. The sugar clings in thin layers, and the surface begins to sparkle under the warm light. The final polish comes from roughly 200 grams of carnauba wax. The drums turn at 25 revolutions per minute, and each jelly bean reflects tiny flashes of light as if polished by hand. This is what gives them their signature glossy finish. The beans clatter in the drums for hours, emerging uniform and sparkling. To the eye, they now look ready, but machines still must sort and weigh them. Automated systems funnel beans onto conveyors. Optical scanners remove any irregular shapes before filling begins. Before packaging, food-grade inkjet printers mark tiny logos or letters directly onto the surface of each bean. These nozzles can print more than 1,000 beans per second, giving them the signature identity people recognize instantly. Precision scales measure exact portions down to a single gram. Each bag holds about 200 grams. Boxes range from 1 to 2 kilograms, and large jars can reach 5 kilograms. Filling takes less than 5 seconds per container, and a single line can prepare up to 20,000 packages per hour. Sealed packages roll onto pallets stacked 1.5 meters high, each carrying nearly 500 kilograms of product, before heading to warehouses for nationwide distribution. Thanks to airtight sealing and controlled storage, jelly beans maintain freshness and texture for 12 to 18 months. That tiny candy in your hand is the product of an enormous, unseen effort. From candied fruit that takes 10 days to soak, to jelly beans with more than 200 sugar coats, to marshmallows made of air and syrup, every sweet hides a story of patience and precision. Factories turn fragile ingredients into products that last months or feed entire holidays. Machines hum, mixers whip, and dryers blow, all to create the candies many of us link to childhood memories and festive traditions. Each bite feels simple, yet the path behind it is anything but. If you want to uncover more hidden secrets inside the world's factories, subscribe now to Captain Discovery and keep exploring with us.